Hi, welcome. So today I'll explain you about the Stardust POC demonstration. So this is part of a EU project called 5G-STARDUST, and what we have here showcased is the NTN-TN backhaul connections. So the testbed basically looks like this. What we have here is we have a central core which acts as a backhaul, and then we have a end-to-end core which is this yellow core networks. This is over the top for this backhauling. So the idea is the end-to-end core is switching over this TN and NTN links, and these links are controlled by the IAB and the backhaul core network. And here we are mainly to simplify, it's basically a scenario where you have both links available, and if there is a problem with one of the links or if there is a channel has issues, that time the link will be switched to another one which has the better capacity and better latencies. So today in the demonstration we are mainly showing about this end-to-end link as well as how the changes happens and if there are any effects on it. This is our testbed which is in Thales, Alenia airspace, and our POC bench. This is the whole setup diagram with management network, access network, and different types of network. And mainly here in the box we see the small SLE. This is which is doing the adding the Doppler effect and other modulations in the NTN channel. This is the setup we are showing today, which is we are pushing a feed from the user core network here in the data network. From here the feed is going through the user core. From backhaul it initially goes over the TN link to IAB to the final UE, and here we are running a web browser which is showing this feed. This we will see in a minute, but at the same time we have a second path here which is this NTN link. So we have feeder link. This is for now a simulated one, but this service link is actually via a SLE which is adding Doppler. So in this case this is actually doing Doppler calculation. So the UE is receiving the satellite information via the SIB19 messages, and it's estimating the next second for the satellite position, and then it's accordingly keeping the track of this connection. And at this IAB we will do the switching between if the data is going via TN backhaul or NTN backhaul. We are sharing the desktop over the Teams session because Teams is good for, let's say, video sharing platform instead of any VNC type of stuff. And here what I would like to focus is mainly this numbers, which means if these numbers are moving, it means we are receiving these frames, audio and different bit rates. And here we see the current bit rate of the feed, which is changing between 1 Mbps to few kbps. And the idea is this feed has to stay constant when we are switching between TN and NTN link to show that this backhaul switching is completely transparent to the backhaul, which is TN or NTN. And for this simulation, what I have here is I have a bit of shells running. So just to give you a brief information about, so starting from here, this is NTN Gnode B as it's written. Then there is NTN UE which is connected to this Gnode B, and we have NTN UE data path, which is basically just showing the data which is going through this link. Just to give you an information, this is a simulation in the sense the satellite has a 5-minute time delay, I would say, that the satellite passes over the UE in 5 minutes. So this is why I need to restart my simulation every 5 minutes so that I can show that the UE is actually connected. So for now we can see it is stopped at 398 because the satellite has already passed over the UE. Now if we see on this side, I have a TN Gnode B, I have a TN UE, and I have a TN UE data path. So this is all TN stack, and here we can see it is pinging over this TN link. So now quickly to jump back onto the diagram to show what we saw. So for now we saw first the NTN channels, then we saw the TN channel, and now we will see this final end user UE. So here this is the final end user UE's Gnode B, and then the UE is present here, and then this UE's data path is shown here. What this means is this data is going from the user UE via the TN UE to the core network. And the IAB node, which is doing the switching, is controlled by these two shells. Here we are running a tracker which is keeping track of if the TN link is up or TN link is down. But since we don't have the physical access to the box, we have to execute some script to block the links and then do the switchings manually. So I will just restart my simulation here. For this, I need to restart basically my UE. So once the UE starts, we should see the ping resume. So now we see the pings resuming. So now, which means the satellite link is connected, TN link is connected, and here we see the pings are in 40s of milliseconds. So what I will do now is I will trigger the blocking of TN link, which will basically shift the final UE's data connection from TN to NTN. So now the TN link is blocked. If we see here, from 60s it jumped to 300 plus milliseconds, which is basically the same latency as we are seeing for the NTN link. And at the same time, this video is still going on. After 5 minutes, we should see the video is frozen. The reason is at that time the satellite would have already passed over the UE, and we have not re-switched the connection back to TN link. As of now, this is manual switching, but in the scope of the project, we are aiming for automatic switching and a multipath connectivity to send the data over TN and NTN link at the same time, and we can control which bearers are going over TN path, which bearers are going over NTN path. So now it takes roughly 300 seconds for the satellite to go, but to show here, I can for now just kill this UE. I can keep it side by side. So we have the feed running. If I kill the UE, we should see the feed frozen. So it's now frozen. The numbers are not moving anymore. And if now I unblock the NTN link, the feed should resume. So now this feed is going over TN link. So this is our demo showcasing the switch between TN and NTN backhaul, which will be transparent to the end core network and end users.